In 7.3, we're going to work on hypothesis testing some more. We'll still be testing population means, but this time we'll be using t instead of z. So to find the p-values that we need on the calculator, we'll still go to the stat button. We'll still arrow over twice to get to the tests menu. And this time we'll look for option number 2, t-test. And then we'll enter in the information and calculate or draw. By the way, if you're having any trouble with the draw, it might be because you have some other plots turned on. So you might press second and then y equals to make sure all those other plots are turned off. And then you'll be able to draw those. So the example here should be one where we need to use t instead of z. If you recall from chapter 6, we use t instead of z when we don't know the population standard deviation sigma. So let's see if that's the case in this problem, where an oceanographer claims that the mean dive duration of a North Atlantic right whale is 11.5 minutes. A random sample of 34 dive durations has a mean of 12.2 minutes and a standard deviation of 2.2 minutes. Is there enough evidence to reject the claim at alpha equals 0.10? Assume the population is normally distributed. So let's see about this standard deviation, 2.2. That 2.2 is describing the random sample, so it is not a sigma value, it's just an S. The standard deviation of the sample is 2.2. That's how we know that t is needed here, and we're not able to use z. So we also have the mean time for that sample and the size of the sample. That'll be our evidence, help us to test the claim. So the claim is that the mean dive duration is 11.5 minutes. Is would be an equality, so we want to put that next to the null hypothesis. And we want to keep in mind that that was the claim. The opposite then will be our alternative hypothesis. And you might recall we know that a not equal for the alternative hypothesis means we're talking about a two-tailed test. So let's put the data into the calculator and see what we get for the p-value. See what our decision is. So we said we want to go to stat, over to tests, choose item 2, t-test. Make sure stats is highlighted, and then let's enter in all of our numbers. For mu, we want the number from the claim. That's the population mean that we're testing. And then x bar is our sample mean. S is our sample standard deviation. And sample size. Notice the calculator wants to know what alternative hypothesis we're using, just like when we were thinking about it being a two-tailed test. So down to calculate, and the number we really need here is the p. On the homework, MyStatLab, they often ask us to round it to 3 places, so let's round that to 3 places, 0.073. And on the screen there, notice also t equals. That's the standardized test statistic that they sometimes ask about in the homework, and it's usually rounded to 2 places. So let's round that to 1.86. By the way, that's letting us know where this shading cuts off. So we know a positive 1.86 on the right, and the mirror image would be a negative 1.86 on the left. So back to the p. We want to just compare it with alpha. The alpha in this problem was 0.10, and it looks like 0.07 is smaller or less than 0.10. 7 is less than 10. So when p is less than alpha, the decision we should make is to reject the null hypothesis. And if we think back to where the claim is, that'll help us interpret. If we reject the null hypothesis, then we're going to go with the other one, which means that we are, in this case, rejecting the claim. Because the null hypothesis is the claim, rejecting the null means we're rejecting the claim. So there is enough or we could say sufficient. There is enough evidence at the 10% significance level to reject the claim that the mean dive duration of North Atlantic right whales is 11.5 minutes. On the next page, we have a detailed list of all the steps we're going through. And you will notice, I think, that it is almost identical to the similar page in the previous section. The thing is that we're talking about a t-test here. So this is for when sigma is unknown. And that is really only reflected in the first step where we want to verify we don't know sigma. And the way we conduct the test is really no different. It's just that we'll use the t-test to find our p-value instead of the z-test. So on the next page, there's a problem for you to try out. Here's a good time to pause the video, see if you can find everything you need, and decide whether that hypothesis is going to be rejected or not. So what makes this one a little different is we have a raw data, or in other words, a data set, which is where we need to find X bar for ourselves. So we'll put that data into list 1, and we'll go to stat, calc, one variable statistics to find the X bar, 10.05, and the SX, 2.49. That'll give us the information we need then once we've set up our hypotheses to find the standardized test statistic and the p-value. So that again is from going to the t-test, putting in all the numbers here, making sure the correct alternative hypothesis is selected, and calculating. If we're asked for the standardized test statistic, that would be the negative 1.08. The p in this case rounds to 0.315. That's greater than alpha, so our decision should be fail to reject HO. If we fail to reject HO, we're going to stick with this statement, which means we're not rejecting the claim. Because HO is the claim, if we fail to reject HO, we fail to reject the claim. So there is not enough or not sufficient evidence at that level to reject the claim. Remember back on that t-test, we have another option at the bottom. Instead of calculate, we could select draw, and we'll see then the shading, in this case, in both tails. And we kind of have an idea then of what that negative 1.08 was telling us. So 0.315, the p-value is the size of the shading, and the standardized test statistic, negative 1.08, is the cutoff for the shading.